This is Unit 4, Lesson 4, Scale and Map Problems. Scale drawings, or scale models, are representations or copies of an object that is larger or smaller than the actual size of the object being represented. The lengths and widths of the objects on a scale drawing or scale model are proportional to the lengths and widths of the actual object. I'm going to use this when we do problems. So we need to differentiate between scale and scale factor. The scale of the drawing or the model is the ratio of the measures of the drawing or model to the measures of the actual object. An example would be 2 inches of the model represents 3 feet of the actual object. If the scale drawing and the model have the same units of measure, the scale can be written without the units, and this is called the scale factor. So you could see here that the scale factor is 1 to 24. That would mean they have the same units. Their proportion is 1 over 24. All right, example 1. The pillars of the World War II Memorial in Washington, D.C. are 17 feet tall. A scale model of the memorial is being built at a scale of 1 inch equals 3.4 feet. What should the height of the pillars be on the model? Well, we can use a proportion to solve this. The first thing we want to do is define our variable. What we don't know is the height of the pillars on the model, and I'm putting there that it's going to be in inches. That's going to help me when I go to write my sentence at the end so I know what the units are. So I'm going to set up a ratio using the model, which is in inches, and the actual object, which is in feet. So I like to write that as a ratio before I get started, and then I can make sure and put all the pieces of information in my proportion in the right place. So I first write my scale. I know that it's 1 inch for the model and 3.4 feet for the actual object, so I write that as a ratio. So at this point I look and I say, okay, I know that the actual pillars are 17 feet tall, but I don't know the height of the pillars on the model. So I put those 2 pieces of information in a ratio, looking to see model goes on top, actual goes on the bottom. Now it's just a matter of cross multiplying to solve for x. There we go, x equals 5. What is my x standing for? The height of the pillars on the model in inches, and so I go ahead and I write my sentence. The pillars will be 5 inches tall on the model. Now remember, you should be writing all of this down on your note sheet exactly as you see it here. All right, example 2, you're going to give this one a try. A map of a natural history museum shows that the dinosaur exhibit room is 7.25 inches wide. If the scale on the map is 1 inch to 8 feet, what is the width of the actual room? All right, I'd like you to pause the video and go ahead and give this one a try. Oh, you did. First thing I'm going to do is define the variable, and notice that I'm being very particular. I'm specifying the width of the actual room. I want to write actual versus model so we know which is which, and I'm putting my units in there in feet. All right, so I'm going to make a ratio, inches and feet. It doesn't really matter whether you put the inches in the numerator and the feet in the denominator, or if you reverse it. You just have to make sure that your actual proportion uses the same ratio that you use when you write it in words. All right, so we know 1 inch equals 8 feet. That's the scale. I'm going to go ahead and write that down, and now I know that the scale, the map, has 7.25 inches, so I'm going to put that in the numerator, and we don't know the feet. That's in the denominator. Now we're going to go ahead and cross multiply to solve, and this is a pretty easy one because we have 1 times x equals 8 times 7.25, so it's pretty straightforward to get to x equals 58, and that stands for the width of the actual room, so we write the room is 58 feet wide. All right, here's another example. Many of the examples we'll be doing involve the scale on a map. So you can see here is a map showing different points, and at the top is a close-up of the scale, and you can see that measuring the scale with a little ruler shows that 2 centimeters is representing 200 meters in real life. So what we don't know is the actual distance from point A to point E in meters. That's what the question is asking. I'm going to set up my ratio, the centimeters from the ruler on the map to the meters in real life. So now when I take a look, that's the scale on the map. 2 centimeters represents 200 meters in real life. So I'm looking, and on my map, I've measured from point A to point E with a ruler, and I see that it's 8 centimeters. So I can set up another ratio, 8 centimeters. We don't know what the meters are in real life. Now it's a matter of cross-multiplying, solving, and getting x equals 800. If I'm not sure what that means, x equals 800, I look back at my defined variable. It says that's the actual distance. So it's 800 meters from point A to point E in real life. All right, one more example. You're going to try this one. Lila is painting a mural on a wall that measures 27 feet long and 15 feet tall. Lila makes a sketch of her design on a graph paper where each 0.5-inch grid represents 3 feet. What will the dimensions of the sketch be? So now, this is important. This is really 2 problems in one. The length and the height are going to be done as 2 separate problems. So I want you to pause the video and do these 2 separate problems. All right, let's see how you did. The first thing I'm going to start off is trying to figure out the length of the drawing in inches. And I want to set up a ratio, the mural, in feet over the drawing in inches. Now again, you might have had the inches on the top and the feet on the bottom. That's fine. Yours is just going to be switched around from the way mine looks, but your cross-multiplying will still be the same. So I'm going to represent the mural as 3 feet and the drawing is 0.5 of an inch. And so when I'm talking about the length, we know the length of the mural is 27 feet long. So I set up my proportion, then I cross-multiply to solve, getting x equals 4.5. Now we're going to do it all over again with the height. There's our ratio. We know this time the height is 15 feet. And don't forget, there's another way of solving a proportion. When you realize that the way to go from one numerator to the next is easy with multiplication. We can multiply 3 by 5 to get 15. So we can do that process to get our x value and do 0.5 times 5 equals 2.5. Therefore, we know x equals 2.5. So we can answer in a sentence, the drawing will be 4.5 inches by 2.5 inches. That's it. Put your note sheet in your binder. I'll see you tomorrow.